Hi. So today I'll be talking about an alternating series test. And basically what an alternating series test is a test that is used to determine convergence. It is used to determine convergence in a series that deals with negative terms. Not only it deals with negative terms, but it also deals with terms that alternate between positive and negative terms in its series. So for such a series, b sub n, it will be equal to b sub 1 minus b sub 2 plus b sub 3 minus b sub 4, and so on and so forth. What is significant here, or what pops out immediately, that for all our negative terms, they are even, and we can see that our odd terms are positive. And we need to keep in mind though that our b sub n should always be greater than 0. And so to know or to determine whether such a series converge or diverge or does not converge, we need to show two things. The first thing we need to show that this b sub n that we have here and here also, it should always be greater than a b n plus 1. In other words, we can use an example that is often used to explain alternating series, which is that if we have something like 1 minus half plus 1 over 3 minus 1 over 4, and so on, we can immediately see that 1 is greater than half, and then half is greater than 1/3, and then 1/3 is greater than 1/4, and so on and so forth. And if we satisfy that, then we can check off the first condition here. And what we also need to meet is that the limit as it goes to infinity for the series b of n should always equal to 0. If we have these two conditions met, then we can say that our series is convergent. Let's put this in other words in terms of a graph. If we have a certain number line, okay, and we need to graph our b of n as a horizontal line. Here we'll have our 0, and here we'll have a certain b of 1. And what is significant here about this b of 1 is that it goes a certain distance from 0. We'll call this the b of 1. And for this line, we'll call this line s of 1. Okay? Now, going back to our series, which I can put here, we said that we need to subtract to get on to b sub 2. And so to go to b sub 2, we need to go in the other direction and subtract, and it is lesser than b sub 1, and so be somewhere here, and we'll call this s sub 2. And we have to now add in order to get b sub 3, and again it is lesser than b sub 2, so it'll be somewhere here. I'll put this in another color, and that will be our s sub 3. And again, here when we went on from here, we subtracted to get to here, and then we added to get to the s of 3 line. And if we need to get to s sub 4, we need to subtract also a b sub 4, and so on and so forth. I can put this in a neater and better picture. What becomes clear after graphing our series here, that the partial sums of the even terms that we have are increasing, whereas the partial sums of our positive terms are decreasing. And in both cases, though, they're all approaching a certain term s, and this term s can be considered the sum of the series. So they're going back and forth from adding into subtracting, and they're all converging between this s that we have right here. Now, aside from all of that, let us see an example to illustrate what we were just talking about. And if we have a certain example, say if we have n equals to 1, and then we have our minus 1, okay? And so what we need to always also keep in mind is that the power that the minus 1 is raised to often determines what terms should either be negative or positive. We can have here another case, for example, where this could be minus 1 to n bn, and our terms as a result will start with a negative number and then go on to a positive one. And so oftentimes the power that the minus 1 is raised to is what dictates what terms, whether odd or even, get to carry the negative sign. And so, but back to our example here. Remember, I'll put up the series or the conditions that we have to meet, and we'll solve this example. And so what we first need to show is that we can illustrate or put the series in another words. So I mean, we start solving for the series. So if we have such a series starting from 1, our first series is going to be, say, minus 1, sorry, minus 1 over 1 plus minus 1, 2 minus 1 over 2 minus 1 plus 3 minus 1 3 minus 1 in the bottom, and we could keep doing that. Eventually we will get to the answer, which is going to be 1 minus half plus 1 over 3 minus 1 over 4, and so on. The first condition that we have to check whether our terms that come after the first term are greater than or equal to it, or less than the terms that follow the first term are less or less than it. And so here we can see that, of course, the first condition of b n plus 1, which is 1 over n plus 1, and we can see that because 1 is greater than, okay, so the first condition here is met. The second condition, which is checking for the limit, we can see that the limit of 1 over n as n goes to infinity, in this case, is rather equals to 0, which determines or satisfies the second condition that we have here, concluding that the series here that we have is convergent by the alternating series test. And that will be it.